I want to talk about ground truth. I want to talk about feature engineering. And I want to have you guys show off your M2 solutions, your Module 2 solutions. And first, are there any questions about the course, the homework, anything else you want to talk about?
I think I also have a task.
You have a, sorry?
Task? Yeah. You
Oh, and yes, and you're going to, Liu Tengyi is going to present. You're going to do bias and variance for us?
yeah.
Excellent, excellent. So we'll do that right after feature engineering, okay? I'm going to talk briefly, or the first thing is just to lead a discussion, but this is my experience, very important and something I think students struggle with a little bit. And I'm going to use a question that you may have thought about or should think about as a way to introduce ground truth, okay? So what is the difference between data analytics and data science? Yu Chen, yes, sir.
Yeah, from my perspective, data analytics is use historic data to get some insight, but data science is, use the data to predict the trend in the future.
Okay. All right. Thank you.
I think data analytics is which is to analysis of data, like whatever we have. But data science, as in we dig more into it, and like we find the answer to why that one thing is happening. I think so.
Okay. Thank you, Ashwarya. Anyone else?
I think data analytics is just one field from the data science, we can say, like one small field, like we have all the data available and we are doing analysis on it. But in data science, we have to prepare the data also. Like preparation will come in data science. Yes.
Okay.
And there is more scope in data science, like doing ML and AI.
Okay. Thank you. So we have three smart people who all have spent time in the field. And let's suppose that you work for the human resources department at Google or Alibaba, right? And they have 100 new jobs that they want to post to get candidates for. And they want you to look at the 100 jobs and decide for each of these jobs, is the job for a data scientist or is it for a data analyst? Okay, with me so far? So if Yu Chen, Ashwarya, and Apurva were tasked with labeling those, and that is a job that HR departments do. They look at the job duties and they give it a job title, right? But if these three smart people with a lot of knowledge of the field labeled the 100 resumes, I'm sorry, job requirements, resumes respond to the requirements, right? Do you think they would come up with the same labels for which ones were data analysts and which ones were data scientists?
I think there will be difference. Yeah.
Okay. Do you think they'd be mostly the same, but some differences? Yeah, I think so too. Now, let's take another case. Let's suppose you're charged with looking at customer churn. You know, you work for a company, like a cell phone company, and you want to know which customers have left to, they didn't renew their contract, right? If I ask 3 people to look at the data for the company for customer churn, how similar do you think their labels would be? Assuming you have data about who's left the company. So not to predict who's going to leave, but to label who has already left the company, what degree of accuracy would you expect from those labels? Would it be high accuracy or low accuracy?
High accuracy?
So you say it would be more than labeling data analytics versus data science job requirements. Higher accuracy than that. Yeah,
Yeah.
I think so
Yes,
too.
yes.
Yeah.
So depending on the problem in front of you, ground truth is, it can differ, right? Like customer churn after the fact should be pretty accurate. I mean, there may be some data entry error there or something, but in general, it should be close to 100%. Other things like data analytics or data science, or is this movie review positive or negative? The ground truth is a little bit squishier, right? And when you're doing work in data science or data analytics, it's if you're working with predictive analytics like regression or linear regression, supervised learning, which is most of what this class is about, it's important to really understand, how the data was labeled, how accurate it is, et cetera. So if you're trying to create a machine learning model that predicts with 100% accuracy whether something's data analytics or data science, that's really difficult to do because there isn't really consensus among human experts which is which, right? And let's say you wanted to create an experiment to label job requirements as data analyst or data scientist. Can anybody think about where they might get the data from? Where would you get a bunch of job requirements? If you don't work for Google, if you're a student researcher, for example.
Some like LinkedIn,
Yeah,
platform like
Yeah.
Indeed, Handshake, something like
yeah. So there's a lot of job boards, and you could look at the job board and see, was this, you could say, give me 100 data science jobs in the New York area from LinkedIn, from Indeed, say, and give me 100 data analyst jobs. But so those would already be labeled, right? But if you look at them, I think you might disagree with some of the labels. Now, again, I don't think there's 100% ground truth consensus, but I did want to weigh in a little bit on Yushin and Ashwarya's, or especially Yuchen's discussion, because there's a lot of different ways to look at data, right? And Tom Davenport, who writes a lot of books, Tom Davenport writes books for CEOs of companies with names like Competing on Analytics, Analytics at Work. And he just came up with a book on AI. But they're really for CEOs of companies to understand things, right? But I think he's still very smart and useful. He says, for example, that when it comes to analytics for data analyst and data scientist, that one could have descriptive analytics that describes historical data. predictive analytics, which is, predicting whether something is A or B. He says there's prescriptive analytics, which is to support decision-making, and autonomous analytics, things like self-driving cars and reinforcement learning that plays Go and flies helicopters upside down and things like that, right? So I saw an interview with a recruiter in the Wall Street Journal, and she was asked the question, what's the difference between a data analyst and a data scientist? And she said that a data analyst is very good with structured data, and a data scientist is very good with structured and unstructured data. And again, I think that's interesting, and I like it, but if it's not a definition that everybody uses, it's useful, but it's not a question with an answer, right? It's not a question with a single answer that everybody agrees on.
Also, can we say that data scientists, they use more of statistics, but data analyst does not?
Interesting. Yeah, I think some people would say that. I would say that data science assumes more math and somewhat more statistics in data analytics. I'd say that I think there's a paper I mentioned last week about the two cultures that data science comes out of, the computer science building and the statistics building. How many of you are taking a stats class with Professor Schulte this semester? How's that going? Okay. He is, he's a long-term friend. He and I we look at the world very differently. Like, he is much more of a statistician than I am. I'm much more of a machine learning guy than he is, right? And I think that good data science is grounded in both things, and that statisticians tend to poo-poo data science. If the p-value is greater than 0.05, you throw it out. To a data scientist, does it provide useful information to the business, right? So, but a lot of data science algorithms are built on top of statistics and even more so probability. So I think what you say is probably generally true, but it's messy. Okay, this was, for those of you in the Fast AI, you may remember this from a video lecture. And what's he talking about here? Does anybody remember this?
Yes, I remember that. It's about how to use deep learning to detect the disease. I don't know if it is cancer or
Yes.
something.
Yeah, but it's actually, it predates deep learning. It's how to do feature analysis without deep learning, right? And the woman that led the team from Stanford, her name's Daphne Koller. And two stories about Daphne Koller. One is she co-founded a little company called Coursera when she wasn't working at Stanford. The other thing is she teaches a course at Stanford in probabilistic graphical models. And one of my students came to me and said, "Can I take this Stanford course as an elective?" I said, "Sure." And he was one of my best students, worked very hard, and sometimes even worked 20 hours a week on a course, right? He came back after taking her probabilistic graphical models course. I said, "How'd it go?" He said, "Oh, I loved it, but I worked 80 hours a week on it the whole semester." And it's because it's very difficult subject matter. And that is data science built on top of Bayesian statistics. So maybe, Ashwarya, that ties in with your argument. But if you look at what Daphne Kohler and her team did, she worked with a set of medical doctors over a set of years. So, this was a millions of dollar project to come up with a better cancer diagnosis. And it was really obsoleted by deep learning methods that didn't need to do the feature engineering. But feature engineering is still very important for unstructured data. By the way, for structured data, what do I mean by structured data, by the way? Is a SQL table, a SQL result set structured?
It's JSON mostly.
Yeah, so I'd say a SQL result set is structured, a CSV file, Excel, a rectangular data is structured. JSON is often called semi-structured data, but I think one could argue that it's structured or relatively structured. So what would be unstructured data?
Images.
Images,
Sounds.
sounds, audio.
Yeah.
Movies are really collections of sounds and images, right? Natural language processing is sometimes called unstructured. But this course, the Topper data science course, uses the first half of Garon's book and a little bit of neural networks, deep learning. So we're going to work mostly with structured data. And I'd say that in terms of buzz, the things that make the headlines, it's mostly unstructured data right now, like ChatGPT-3 and Valley and Dolly, some really exciting things happening with unstructured data. But I think most of the work in companies today is still doing predictive analytics on structured data. So this is still highly relevant stuff to learn, even if it doesn't make the newspaper headlines. Does anybody know what a newspaper is? Just kidding. Okay. All right, let me give an example of structured data. So Kaggle had a contest. It was like, what's the name of a big company that sells used cars? Does anybody know of a company like that? Like CarMax. Has anybody ever heard of CarMax? I guess if you live in the New York area, cars aren't such a big thing, right? But there are companies in the US and presumably other places that have hundreds of thousands of cars that they're selling. And they sponsored a contest on Kaggle, and they gave a lot of information about each car, the year, the number of miles, the Blue Book price, et cetera, et cetera. And the task was to identify which cars were better bargains, which ones were more valuable than the price, which, by the way, is the same thing stock analysts do and stockbrokers do. They're looking for arbitrage opportunities on the market, right? So people took this structured data, things that seemed unimportant, like the color of the car and the mileage, where it was driven, et cetera, and tried to predict the actual price relative to the Blue Book price. So the differential, the goal is to maximize the differential. Everybody with me so far? So what is feature engineering? What does it mean to do feature engineering on a data set? What would be an example of feature engineering on just any example of feature engineering on a data set?
Just based on exist column or features and generate some new information from them. Like,
Yeah, that's a good general definition. Great.
Yeah.
Can you now give a specific use case or example of that, please?
Yeah, for example, if we only have DOB, data of birth, in data set for each individual, we can just use 2023 minus your year of born and get your age.
Okay, so you could convert date of birth to age. Good.
Yeah.
Once you've converted to age, what might you do with that?
After converge to age,
Yeah. Could you do more with it if you wanted?
yes, we can do more like convert to age.
Are you guys Gen Z, Gen X? Ashwarya, go ahead.
Yeah, maybe we can convert, we can create beans.
Yes,
But-
yes.
Yeah.
So
And
marketing
group,
people like to bin people together. Like I'm a baby boomer and you guys are, what do they call you? Gen Z? What do the marketing people label you as? Not a perva, everybody else. Nobody labels a perva. But there are different terms. At least American marketers, like to think of marketing to groups of people based on their age and binning them into groups, right? So this Kaggle contest had thousands of people trying to come up with the best price. And the winner of the contest had the insight that people who bought cars with unusual colors like orange and green were more likely to take really good care of them. They were the collector mentality types, right? Like Yu Chen's purple shirt. I mean, he loves that shirt. Like he wouldn't even let his corgis wear that shirt, right? So, the unusual things we take better care of. And it turned out what someone came up with the most accurate analysis was they said, if the car was this color or this color, like orange or green, it put it into one bin and all the other colors into another bin. And that insight was enough to create a more accurate metric. Now that required domain knowledge, like someone who really understood car prices and classic cars, et cetera, right? It would be relatively challenging for a computer to come up with that, although a neural network probably would. And you can read more about it, how Kaggle does things here, and I'll post this video, I'll post this deck on the site. It's a good short talk by the president of Kaggle on features. So if you're doing neural networks, well, features are less important. I'd argue they're still important, but the traditional way you determine features are that the data analyst or data scientist sits down with the business stakeholders, right? And they talk together about, which columns or independent variables are most important. Do we need to transform them? What do we do with missing data, outlier data? It's often very valuable to get the business perspective on that, right? I think I told you the first time I did an analysis from an NFL data warehouse, I predicted that the best quarterback was 63 years old because I didn't understand the data set well enough, right? And if I'd had a business expert with me, I mean, fortunately, I wasn't doing it for, ESPN. I was just doing it as a proof of concept internally. But okay, so what might be some, in addition to learning about how to do feature engineering, what might be another advantage of working with stakeholders on features?
You can know their ideas about the project and their expectations, what their wants, what's their fear, and so generally give you the idea of the objectives of making a project.
Yeah, I think I think you said it all. You know, so you learn things that are useful for the project, but you know, understanding their ideas and their goals and their fears. What happens? And I've completely wasted 2 years or more of my life where, you know, I was usually being paid to do it. So, you know, you could argue maybe it was a complete waste because I got a little money in the bank. But sometimes you build something and it doesn't get used, right? And, you know, if your goal is to build things that get used and you spend a year building something and it doesn't get used, that kind of stinks, even if you got a little coin for it. And what I've found is that if you talk with the business stakeholders and you know, they know that you're listening to them and you're incorporating some of your ideas, you're going to get their buy-in. And a lot of the times we don't have the power to change the business, to put things into, you know, we can put it into production, but it still has to be okayed at like a business level. So involving the stakeholders often increases the likelihood that they'll make sure that your work gets deployed. One of the weird and scary things in the US, and I know there's no political decisions in China, right? They just do what's best. Right, Wang Yuchen? Sorry.
I'm not sure.
I'm being facetious. You know, business stakeholders often say, does it help me personally if this goes into production, right? And if there's a business stakeholder whose job becomes less relevant because of this new program, that business stakeholder may fight tooth and nail that it doesn't happen, right? So you need to have people on your side. Now, what's a downside of needing to work with stakeholders? So who completed the homework assignment? Raise your hand if you completed. So Ashwarya, could I ask you about how many hours did it take you to complete the homework assignment, if I could put you on the spot? You can make up a number if you want, because, you know, but just ballpark, how many hours did it take you?
I think 3 years.
Okay, so there's the amount of time it takes to build something, right? And you know, in a work project, it might be 10 hours, 100 hours, 10,000 hours, but then there's the calendar time that it takes. And we know that if it takes one person 2 months, it doesn't take, or let's say it takes one person 8 months, that doesn't mean it takes 4 people 2 months, right? You know, it's not, it's a little messier than that. But in my experience, over a lot of analytics projects, over a lot of time and a lot of different companies, that the scarcest resource on the project is often the business stakeholder who understands things well enough to be useful. Because almost always in my experience, that is one of the most valuable and busiest business stakeholders. So if your project depends on getting time with them, it might be that you don't get to sit down for 20 hours a week with them. You sit down for an hour a week with them. And it can take 8 months just to get the requirements. Has anybody had an experience like that in a work experience? Or heard of such a thing? I mean, it's pretty typical, right? So, you know, balancing, usually my approach is to try and get as much time as I can with the business stakeholders, but understanding what the impact is, understanding how important feature engineering is, depends a lot on whether you're using neural networks or not. And these questions can have a profound impact on whether your work is successful or not. Because your work being evaluated as successful or not really doesn't have a lot to do with whether you're 97 or 98% accurate or your RMSE is X or 0.8X. Those things matter. All right, let's talk about this second item. If you were to, well, yeah, let's do the second one first. This is more like EDA than feature engineering, I suppose, at least this one is. If you were to choose an algorithm, and given that we're just starting the course, this is an unfair question, but if you were to pick an algorithm to divide these two types, this classification, cats and dogs or whatever, what algorithm could you use to do that? Does anybody know of one?
Any algorithm that can,
Any algorithm.
okay, maybe decision tree.
Okay, maybe a decision tree. Yeah, that would probably work.
Or KNN.
Yeah, KNN would definitely work.
Yeah.
Support vector machine. I mean, you understanding what a decision boundary is and what it would look like, it would be easy to create a decision boundary that does a good job at separating these. In fact, it would do a perfect job of separating this data, right? Let's talk about the third one. Can you draw a line that separates these, the blues from the oranges? So a regression model wouldn't work very well here. A decision boundary would be tricky. K nearest neighbor seems like it would be difficult. What would work really well here? You said it earlier, Wang Yuchen.
Decision tree?
A decision tree. And if you understand how a decision tree algorithm works, it splits things up into rectangles, right?
It's Gini.
Yeah, and so that Gini is rectangle by rectangle. It bisects the data set, bisects the data set. So this would, a decision tree or random forest would perform really well here. And sometimes with the data set, lots of things perform well. Okay, this last one's really tricky. This is more of a feature engineering question. How could you transform this data so that it would be easier for an algorithm to work with it? So here's decision trees. And you can do a feature engineering. Often we do feature engineering transformations. We take a log of data that's nonlinear and make it linear and then do a regression on it. But another thing that you do much more rarely, but sometimes, is you could take your polar coordinates and convert them to Cartesian coordinates and then do your analysis. So sometimes there is a math problem up front. Okay? And there's a bit of a chicken and egg issue with feature engineering and EDA and building models that, for example, those of you who were are in the FAST AI, you saw the Titanic data set analysis where the professor normalized a lot of the fields. He basically, normalization, one way to do it is you take the maximum value and you subtract, how's it go? You divide the value by the maximum value, and then all the values are between 0 and 1. And with standardization, you do that and divide it by the standard deviation. And but with linear regression or k nearest neighbors, if you have some values that are really big and some that are very small, you get a very skewed model, right? An inaccurate model. But with decision trees and things that come from decision trees like random forest, you don't. So some algorithms for data science, you can't have missing data. Some you can. So when you're cleaning your data, when you're doing your feature engineering on it, knowing what kind of algorithms you're going to work with may drive some of your decisions early on, right? You know, it's a hard field. Okay. I'd like to now introduce a guest lecturer who has come from far away. Liu Dengyi is going to present. So Liu Dengyi,
Yeah.
give it up for Liu Dengyi.
Thank you. Thank you. It's for the BIOS virus. Yeah.
I'm sorry, Liu Dengyi?
So it's for the task you give me the last week, or
Yes,
okay,
please.
okay. So last week I read the paper Professor Andy gave me and make this presentation. So it's about BIOS virus and our feed and on the feed. So firstly, when we look at this bullseye diagram, there are four of them. So this one is low virus and low BIOS, and high virus, low BIOS, and this is low virus, high BIOS, and this is high BIOS and a high virus. But so we want to know what they really mean. So when we so look at in our model, it has mostly three situations. First is underfitting, and we want its optimal model, and also has a overfitting situation. So actually, the bullseye diagram can relate it to these three situations. Actually, when we want to make this more intuitive, we can, in this, it has two axes. So if it becomes just one axis, it can be more intuitive. So we can look at this. So definitely this situation is optimal model because as we can see, the red target is our the red point is our target, and the blue point is our model. And this situation, we can see that it is very close to our target, and at this point are like in a very close area, so it has a low variance and low BIOS. So definitely it is the model we want is the optimal model. And for this one, it's kind of in a closed area, but there is some it has a high variance because I think it's very intuitive. In math, it has a high variance, so it means like he's trying to fit as many points as possible, but it's kind of just too much. So it's like a overfit model, and for this one, it's an underfitting because it is too far away from the target we want. So also we can make these three diagrams together, and it will be more intuitive for us to know. So for the underfitting one, we can see in this. So the red point is our target, is our what we want in our model, and for the red point, the green point is a prediction. So in this one, we can see that most of the points in our model we made is too far away from our target, but it's aggregate in one area. So this means it means it has a high barriers, but according to that, he's aggregate in one area, so it has a low variance. And for this one, the overfitting situation, in this situation, he's trying to fit as many points in the model as possible. But most of them are trying to, like close the target you want. So that's why overfitting has a high variance, but a low bias. But there is another situation that's high variance and high bias, where I searched it in Google. So Google said that this is a double bias variance trade-off. So absolutely, this is a very bad situation. So to improve this, to like try to make this not happen, we have many ways to do, like make the data, make a regularization, or maybe use a cross validation to check it, like we just do in our assignment, or maybe simplify the model, because sometimes it's because the model we made is too like it's not simple enough, so it will make overfit. So that's all. Thank you.
Thank you, Liu Dengyi. Excellent job. Questions, comments for Liu Dengyi?
Yeah.
People sometimes talk about a bias variance trade-off. What does that mean?
It means just it's also it's both like overfit and underfit.
Often when you try and reduce the variance, you increase the bias and vice versa. So, it's hard to get that ideal state where it's all clustered in the right place, because data is noisy and there's issues with it. But so sometimes you have to decide which is more important to you. Peck, what do you think? Bias, variance, underfitting, overfitting, is this stuff important?
Yes, it is very important, especially for the research stuff.
Yeah. Spoken like a PhD, which Peck is. Okay, thank you, sir. All right, I'd like to get a volunteer to show off their assignment 2 solution to us. Who will go first?
I can go first.
Great. Thank you, Wang Yu Chen.
Yeah, but strictly speaking, I didn't finish it but anyway, let me just share my screen. Where is that? Oh, sorry, give me a second. It's here. Sorry, something wrong with my. Yeah, can you guys see my screen?
Yes, sir.
Yeah. So this is my assignment of cross validation on the cars data set. And here I just import some necessary libraries and load data. I upload data in my GitHub, and this cell is load data and give them the correspond head And here's data overview and data shape, only 205 rows, 26 columns. And after I checked the data types of each columns, I noticed that some of them are, the types are not appropriate. For example, the price, and also, number of cylinders. They should be numeric, but they are object. So I just check why they are not appropriate, and print the unique values in each column, which is object columns. And I noticed that there's question mark in some in some columns above. So that's the reason why they are objective but not numeric. So after that, I just replaced question mark with non-value and convert them into numeric data type. So after that, I checked the statistical summary of the data set, and they are appropriate now, and no duplicate value, and there's still some missing value in these columns. So after that, I did some EDA works. There's two functions that can generate histogram and box plot together, and also labeled bar plot. And these two functions, we Deng-Yi and Xiangxin and me created these two functions in Professor Topper's class. So I just use them directly. And here's the univariate analysis. It's box plot and histogram for each numeric column, and I write it in a for loop function, and we can notice that almost columns in numeric columns are highly right skew, and so many outliers here. And so I checked some, I create this bar plot for object columns, and get some chart here. So some chart here, bar chart here, yeah. And after that, I did biovariate analysis. The first one is a correlation check for each numeric columns in data set. And we can notice that there are so many columns are get a high correlations. For example, like crop weight, our target variable, and this high V MPG, the correlation is about minus 0.8. And here's another pie plot I create. I think it's very similar to this heat map, but just display as a scatter plot for each two variables. And yeah, and after that, I also create some box plot, and y-axis is our target variable, and check if there are some significantly different among the different values in each column. For example, this one is about make versus crop weight, and this one is a field type versus crop weight, and so on and so forth. And yeah, there's some chart here. and we can get some insight from this chart, but I didn't, write down. And after the EDA work, it's about data preprocessing, because I noticed that the PDF file about this assignment only asks us to select this variables to make them to create a linear regression model. So I select these variables and check them again. There's still some missing value in horsepower and peak RPM. Again, pair plot and heat map. So after that, it's duplicate cell. And after that, I use use the medium and group by function to to fill out the missing value in these two columns. And here's the imputer, and we can just set up the strategy equal to medium, and and after that, there's no missing value in our data set right now. And so next step is data preparation for modeling. The first model, I select these three independent variables: horsepower, peak RPM, and height, because these three variables get a lowest correlation with crop weight. So I just select these three, and I want to create another the second model with some high correlation between the independent variables and crop weight. So this one is the first one, and here's the independent variables and the target variable, and split data into train and test data set, which test size is 0.2. And here's the train and test shape. So next step is build a model and get R-square. And we use cross-validation function. So this one is the function that allowed us to to create 5 different folders in our training set, and I set K to 5, and here's the scores, R-square scores for each folder in different in each folders, and means and average R-square among these 5 folders is 0.75. The second model, I select some like this lens, wheelbase, and CTMPG, something like that. There are 1, 2, 3, 4, 5 independent variables. So before I make this model, I believe the R-square is higher than the first one because I select more independent variables. So in linear regression, no matter the independent variables has high correlation with target variable, but if you select more independent variables, you can get a higher R-square. So the same steps, and I got a R-square, average R-square nearly 0.9, which is 0.89346. So so here's the conclusion, and but after that I generate I create another model. Here's some basic work. Because the first and second model, we just create our linear regression model based on some numeric columns. But in this model, I want to create the models based on not only numerical independent variables, but also some object variables like like this make and field type. So here's some data pre-processing and convert some, like this, the number of cylinder from object to numeric, and also, fill the missing value. Here's some steps that clean the data. And and after that, I get dummy variables for the object variables, like here, like this field system and energy type, and also split the data set into X and Y, and add a constant in our model, and split the data into train and test data set. Test size is 30%, and fit the model. And I got this model summary. Because I use a lot of independent variables, so the R square is really high, which is 0.975. But after that, I think I still need to check some the performance of the model. For example, this one is the performance on training data set, and RMSE, MAE, R square, and ADJ R square, of course, include MAPE. And this one is the performance on test data set. R square is very high, but yeah, as I mentioned before, if you select lots of independent variables, no matter they have high correlation with target variable, you can get a very high R square, but it's not useful. I mean, because we need to test our multicollinearity about the independent variables. So I just check it and use this variance inflation factor method to get a VIF score of each independent variables. And we can notice that there are so many VIF score higher than 5, which means they have a higher multicollinearity among these variables. So we need to remove them one by one and check it after you remove them one by one. But I didn't have time to finish it. I just drop some very high VIF score variables like these 5 variables, and R square didn't change much, and also the adjusted R square didn't change much. And after that, I think I just removed 5 of them, but we need to remove one by one. I think if I can finish that, I will do the next one. Next one is, I didn't write anything below. I think next one is remove high p-value according to this summary, which is if p greater than 0.05, we should remove them also one by one. And finally, we can get a final model. And of course, we also need to check linear regression assumptions after we create a final model. Like I think there are some, the distribution of residue, something like that. Yeah, that's it.
Okay. Nice job, Dustin.
Thank you.
Okay, Apurva? Where are you, Apurva? Apurva, you're the grader for this course, Apurva. What grade should we give Dustin here?
For his work, he can get an A
Okay, so
For sure.
that's an A assignment. Great job. Thank you.
because he was doing a lot of EDA and everything. Like he almost incorporated like all the EDA.
Yeah. Did anyone feel like they did a more thorough job than Wang Yu Chen, or have insights over and beyond what he showed us that they want to show? We may not let you go first every week, Wang Yu Chen, because you tend to squelch things. But so that was a great job. If anybody else wants to present, I'm happy, to give you practice presenting. Like my next appointment's not till 1:30, but I will look at everyone's code as well. Wang Yu Chen, roughly how many hours did you spend, if I could ask,
This assignment,
on this project? How roughly?
5 or 6 hours.
Yeah, you work fast then. That looked like.
Yeah, because yeah, like I mentioned, the functions to create a box plot or histoplot, we Deng Yi and Shangxin and me create last semester in Professor Topper's class. So it make me easier to do some EDA work. So that's the reason why I make it.
Yeah, thank you. Now, when I was a kid, it was before calculators and computers and things like that. So, I spent hundreds of hours in second and third grade doing long division. We just did it over and over and over again. And what one could say in 2023, that was a complete waste of time, right? But I believe that in some ways, all that time spent playing with numbers that could be better done with computers gave me more comfort with numbers and more numeracy. So when I'm working on a problem with people who are younger than myself and are smarter and think faster, I sometimes see them make mistakes where they don't understand the implications of dividing things because they haven't spent a lot of time dividing things, okay? And so I think the kind of work that you're doing here, and I'm talking about Wang Yu Chen because I just saw it, and hopefully everyone else is doing or will do things similar to this, is really time well spent. It's going to really help you a lot with tuning your intuition and improving your Python programming, improving your machine learning, all the obvious things, right? That being said, I want to tell you that I think that there is a sea change happening in our field because of automated machine learning. You saw that Wang Yu Chen did a really excellent project, A for Apurva, right? And an Apurva A. And Apurva, that's the first time I've ever seen him give an A on a project. So with automated machine learning, the things you said you didn't have time for, one could write a computer program to do all of those things simultaneously, right? And come up with the best answer. And scikit-learn is already doing some of that stuff, right? You can give it sets of hyperparameters. Well, maybe you haven't seen it yet, but you give it sets of hyperparameters and it tries lots of different values. And cross-validation, you're not building 5 sets, or you're not having to tell it run this set, then run this set, then run this set. It runs all 5 or 10 for you. And just be aware the things that we're doing that are mechanical recipes the computer is going to do much better, right? And it doesn't mean we shouldn't do it. We really need to build our intuition. If you don't do it, you're not going to be as good in the field as someone who does, right? But just also be aware that when you're doing things that are repetitive, say to yourself, if I had 10 times as much time, could I write something to do all that for me, right? Kind of the meta programming part of it. Or if I could throw 10 CPUs on it at once, because that's what's happening in the field over and over again right now. And I really loved your solution. And my favorite part was saying, when you said, I didn't have time to do this, after you put a lot of time in and did a good solution, right? Because, that's where we are going and where we want to be going. All right. Does anybody else, because we're afternoon, I want to call the class over if people want to leave or, go do other things. But again, I'm happy to stay around and look at other presentations, which I encourage anyone to do who wants to practice presenting or might have questions on it, et cetera. Shwarya.
Yeah, I can present.
Great.
In the last presentation, I have one question. Like in earlier, initially he was replacing the missing values like the question marks with null, like with 0 or null. But later on, like while creating a model, he was using the median value for replacement. So like I guess this was taught in some other class, but like I just want to recall it. Like what should be the approach, like taking the null like value to be 0, or it should be like mean or median or something?
Well, before he converted the question mark, what was the data type?
It was numerical, I guess. Yeah, numerical.
Was it?
Object.
Object. And what is the most common object data type in Python?
Null.
Is string, right?
String.
They were strings.
Okay, string.
Strings report as objects. And could you use, does the mean imputer function work on string data?
No.
So
okay.
He did a 2-step process. Does it look like he needed to first convert the question mark to a null so he could, so he could go to numeric data before he could do an imputation on it? Wang Yuchen, you should answer your own question. You do it better than me here.
Yeah, because before convert them into numeric, they are object, they are string.
Okay.
So I have to convert the question mark into, NumPy none, and after that, yeah, I can.
I thought it was numerical, so that's right.
So Apurva, what town are you in right now?
Sorry, Nagpur in
Nagpur.
Maharashtra.
Okay. What's the high temperature today?
I think it's too high. Like it might be 30 degrees or
Which
something
is
Celsius.
like 90 degrees Fahrenheit, right? Roughly?
86. 86.
And 2 days ago, what was the high temperature about? Roughly. You make up a number.
Yeah, it can be 82, 85. Yeah,
okay.
Similar.
So if 2 days ago it was 82 or 29 or whatever, and today it's 86, and you're missing the data from yesterday, what might you say the data from yesterday is?
Closer to what it is today.
Right, or you might take the average of the
average,
data, or you might take just the value before the value after. So with imputation, imputation is handling missing data, right? And how you do the missing data, sometimes you have to talk to someone with domain knowledge. You have 2 columns in the data set. One is sex, male or female, and another is are they pregnant or not, right? So if you have a male that's not pregnant, is that missing data? I mean, you
No.
yeah. So sometimes there's a really clear answer. Other times you have to guess. Other times you can just get rid of the whole row, right?
Yeah.
Or sometimes the whole column, but you should understand the impact of that. It's very messy. Hey, before Ashwarya goes, I was wondering if anybody would be willing to next week do a presentation on imbalanced data sets. Does anybody want to give a 5-minute talk on imbalanced data sets next week? 2 people can work on it together and do a tag team presentation. Everybody's got to at least once during the semester present. So if imbalanced data sets doesn't grab you, you could suggest something else. But does anybody have something else they want to present for next week? Think about it. Let me know. Okay.
I can do it.
Sorry, Peck.
Yes, I can do it.
You'll do imbalanced data sets?
Yeah.
Thank you, sir. Okay. All right, Ashwarya, the floor is yours, ma'am.
Okay. Okay, you should be able to see my screen.
Yes, ma'am.
So this data, it consists of vehicle details, as everyone knows. And so this is just an introduction. And the data set problems I have faced is there are no column names, or it also consists of missing values, and there is consistency issues. And this is my approach. So I have imported the important libraries. Later, I have read the data set from GitHub and also mentioned the column names, as we do not, as the data did not have any column names. And so after printing the data frame, we can see that there are some missing values. And that is why I'm trying to replace the missing values with NaN. So these are the null values, missing values we have for each column. And this is the distribution, like how it looks, how the null values looks. Yeah, and this is just like a data frame of the missing value columns and how the data looks like, so that we can work on replacing the null values with mean. I've replaced the null values with mean values for each column except price, and also except the number of doors. So for the number of doors, I've seen that most of the values, so these are the 2 rows for which the number of doors is null. And I just took the value counts, and I saw that for 4 doors, it is 114, and whereas for 2 doors, there are 89 rows. So I took kind of median here. So more the number of counts, I have replaced it with the null. So I have replaced the null values with 4 doors. And yeah, so this is the data frame it looks like now. And for price, we had, I think, 4 null values, and I have dropped the rows with null values, as I was not able to, like, I thought it would be great to just skip those rows. And yeah, I've also converted the data, because initially, as we spoke about it, it was object data type. And later I converted it into float while replacing it with the main value. But I wanted it back into integer and others into float. So I've converted the same. this is again, I have just checked the description and the information that how my data looks like now. And it is showing 201 entries because I have skipped 4 price columns, rows. This is the correlation. And just to keep it visually like effective, I've used correlation heat map. So darker the color, we can see there is more correlation, positive correlation. And if there is less like very faint color, there is negative correlation. And I have used the same using just the correlation analysis. I have used the columns, the variables as explanatory variables for my further analysis. So Yuchin, he did really good job on exploratory data analysis, but I thought that this would be sufficient for my work. So I just did the correlation. I just used correlation function, and only based on this, I have did my further analysis. Yeah, so to keep the actual data frame as it is, I have replicated it into some other variables. So this is the copy of the data frame, and I have dropped curve weight from it. Later, I have split the data into X-train and X-test, Y-test into the train test data set. And I have kept the random state as 15, and I have mentioned it specifically because while splitting the data, we should be always aware that we are taking the same rows or the same indexes for X-train and Y-train or X-test, Y-test.
Am I frozen or is Ashwarya frozen?
She is frozen.
Yeah. Ashwarya, I don't know if you can hear us, but you might need to.
She's fasting.
You might need to turn off your video or leave and come back. Ashwarya? Just need to unmute yourself.
Yeah, I'm sorry.
Yeah, you're doing great. Keep going.
Okay. Yes, so this is my model one. Sorry, from where did you lose me? Yeah, from where did you lose me? I'm sorry.
You were showing that X test and Y test, the headers were identical,
Okay.
or had the same rows,
Okay.
same IDs. Right here.
Okay. Yeah. Yeah. Thank you. Okay. So as I said that I think it is always the best idea to mention the random state so that we get the same indexes in the data. Yeah, the same goes for test and train. Yeah. So I've used for model one, I've used CTMPG length and width. And I've chosen this because CTMPG, we can see that it is inversely proportional, it is negatively proportional, and the number is close to -1, almost close to, not much closer, but yeah. And length and width, it is positive, it makes a positive correlation. And this is what it looks like. I've used like a regression model and CV as 5. I've used cross validation score. And so CV as a 5, the K value is 5. That means it is taking the whole data set. It is dividing it equally into 5 or whatever number we are mentioning there. So it basically divides it into 5. And in iteration, I think it uses the first part as the training data set, sorry, the testing data set, and the rest as training. Then again, for the second iteration, it just considers the second CV, that is the second one, and the rest it uses as the training. Again, the third one, and so on. It goes. So it creates the subsets, and so we can see here for second, third, and fifth K value, the accuracy is a bit good. Like it is at least about 80%, and whereas for first and for all 4 it is the accuracy is good. Only for the first one it has the least accuracy. And you can see the R square value. We at the end we are taking the mean of this and calculating the R square value. So it is around 85%. In model to have considered engine size, horsepower, and wheelbase, only 3 explanatory variables I have used for to check the response variable. And this all 3 variables, it directly goes with the curve weight. That is, it is directly proportional, and the correlation is really good. Same here, I have used the same K value, that is 5, and we can see the percentages. And my mean score is around 89% for this. So per this study, we can see that engine size, horsepower, and wheelbase, it seems to have proper fit, and maybe we can do more trial and errors. And as Yuchen did, we can use maybe more explanatory variables to get the response variable. Yeah, thank you.
All right, thank you, Ashwarya. Okay, Xiang Xin. I think that, in my opinion, Ashwarya did a couple things even better than Wang Yu Chen. What would you say was different in her presentation? What did she do that he maybe didn't do as much of? In her Jupyter notebook. Did anything jump out at you as different, or do they seem similar?
I think this seems similar. Maybe in the last part.
Ashwarya, can you bring your notebook back up again, please? And again, I think Yu Chen did a really great job, right? I think they both did. And I think in some ways he was more thorough than her. But yeah, go to the very top. So I didn't feel like Yu Chen had the same kind of introduction she did. Like, she lays out a plan for what she's going to do or describes what she's doing. And at the end, she has her conclusion. And my strong recommendation to you is that in every notebook you do, always have an introduction and a conclusion, or you could call it findings and recommendations. You know, she had findings, and he talked about other things he'd do. Wang Yu Chen, what do you think? Am I?
Yeah.
Did you do it like she did, and I missed it, or am I identifying a place you could do even better?
I did introduction part, but not as much as, you know, but not like Ashwarya, because I'm not did very detailed like her.
Well, in some ways, I think your code was more detailed than her. Right?
Yeah, but not the introduction, because I only write down my, you know, the plan of this project, but not, you know, like much detail as Ashwarya.
Ashwarya, you know, you have a very impressive CV, which I remember. How many years of work experience do you have?
Around 4 years.
Yeah. So she has 4 years of work experience. And I know Peck has some serious work experience, but in a different field. But that's fair to say, Peck.
Yes.
Wang Yu Chen, how much work experience do you have?
Nearly 1 year, I think.
Okay. So, what Wang Yu Chen is, a very gifted and hardworking person. You put those two things together, you get amazing results, right? But I think what Aishwarya's investing more time in her introduction and conclusion is when you work more in the field, you learn that for a lot of people, the only thing they look at is your introduction and your conclusion. And so you want to invest a certain amount of time in them always. Is that fair to say, Aishwarya?
Yeah, right.
So,
But anyways, we do not need to like specify more details, but I think just the bullet points should be enough just to get an idea. Yeah.
yeah. And, if you can't summarize, like if you didn't discover anything, maybe you ask, I like also when you're asking a question of the data, right? To say, what variables correspond most with curb weight? And she has that in the second sentence, but, to have a question, and sometimes in the conclusion, you conclude that you can't answer it. Like there's not enough information to answer the question, or there's not a correlation here or whatever, but it's still good to state that. And so I think this is a good thing that you all should consider doing if you're not already doing it. Just invest a fair amount of time into, letting people know what you're going to do and what you did. It's possible, Wang Yu Chen, that you've been around such bright people, they don't need it, but most people really benefit from getting that kind of summarization and introduction, right? And the better they understand your work, the more they're going to like it. Okay. So,
Yes, sir.
All right. Who else would like to present? Aishwarya, thank you again. Great job.
Yeah, thank you. I just have a question.
Yes,
Like,
ma'am.
is it necessary to so like Yuchen, he did exploratory data analysis and it was really good, it was thorough. But what I did was whatever was useful for me, I thought I did only that much. So
Yeah, it's
how
an
should-
interesting question. I've sometimes heard the difference between, there's exploratory, one definition, there's lots of definitions. One definition of exploratory data analysis is, the graphical and statistical summaries that you do for your own benefit and insights. And then you have your external communications, maybe the presentations, the infographics, the conclusions that you do for external audiences to inform, to persuade, to communicate, right? So if that's true, then your audience for the EDA is yourself. And so that's good. Possibly if you're working in a group or if someone else is going to get your work, or there's an expression in our field that you may have heard. I'll put it in the chat window. Has anybody ever heard that term? It means document things so that when you come back and look at your code 6 months later, you know what you were doing, right? So one argument for putting a little bit more work into your EDA is that it might make it easier when you come back later and look at it and know what you're doing, or you get promoted, which will happen to you a lot, Aishwarya, and other people inherit your code and they don't hate you, right? So, but in general, I agree. The EDA is primarily for you. Okay. Now notice Aishwarya is also talking about, is this useful to do, as opposed to, is this good for my grade? right? And that's again that reflects someone who's been in the world a little bit longer, because if you've never worked before, then value is great, but that really becomes less and less important the longer you are in the field.